So lesson 1.4, we're on elimination. So just like what we were doing before, we're talking about having two linear equations. So equation 1 and equation 2. We've learned how to use substitution to solve these. We've learned how to use graphing. If we were to graph, we'd set it equal to y equals mx plus b. If we were going to substitute, we would set it either equal to x or y in either equation, then sub in, sub out. Now we're going to learn elimination. On your prerequisite skills, you guys did something very similar to this. In order to do elimination, you need to line up like terms. So I have my x's together, my y's together, and my constants together. I'm going to set this up just like an addition or subtraction question. Now, in order for this to work, I actually have to eliminate, hence the name, one of the variables. So when I look at this, I have a positive and a negative y. I choose whether I want to add or subtract these two equations together. I know that if I were to add positive y and negative y, I'm going to get 0. That will eliminate the y's. So I'm going to add both equations. So 3x plus 4x, 7x. Positive y plus negative y is 0. So because it's 0, I don't have to write anything in. It's been eliminated. Hence the name of this. 19 plus 2, 21. Good. So we're just going to move this closer together. I have 7x is equal to 21. Divide both sides by 7. X equals 3. Okay. Now, if I like, I could substitute 3 back in. But what I'm going to do is I'm going to show you how to use elimination to eliminate the x's and solve for the y now. Okay? So we're going to use the same equations. So we'll go to another page. 3x plus y, 19. Can you read me the other one? Do you know what it was?
Oh, yeah, check 4x minus 1.
Okay, now this is the part where it ties into doing equivalent linear systems. If I look at this, whether I add or subtract these two together, or subtract, I'm not going to be able to eliminate the x's. If I add 3x and 4x, I end up with 7x. If I subtract the 2, I end up with negative x. In neither case has x become 0. So what I need to do is I need to change these equations so that they have the same coefficient in front of them. So we have a 3 and a 4 right now. I need to multiply by some multiple and get the coefficients the same.
4 and 3?
That's right. I can multiply by 4 and 3. So I'm going to multiply the top equation by 4 and the bottom equation by 3. So that's equation 1 and equation 2. When I do that, my x's are going to be what coefficient? 12. Very good. So 4 times 3 is, this is equation 1 again, 12x. Positive y times 4 is 4y. And 19 times 4, what's that going to give us? 72?
Sure.
Let's make sure. 4 by 19, 76. I've got to learn my times tables.
I knew that.
Okay. The other equation, same idea. 3 times 4x, 12x. Negative y times 3 is negative 3y. And 2 times 3 is 6. So, now that I have that set up, same idea. I got to make sure my columns are matching. My x's are together. My y's are together. And my constants are together. Put our line underneath. Now I need to eliminate the x's. If I add them together, will I eliminate them? No, I'm going to end up with 24x if I add. So instead of adding to eliminate, I'm going to subtract the two equations to eliminate. 12x subtract 12x will be 0. 4 subtract negative 3. So that's going to look like this. 4 subtract negative 3. That's right. We're going to end up at 7. So we get positive 7y. 76 subtract 6. Good. I got to isolate y. Divide both sides by 7. Y is equal to 10. So my point of intersection between these two systems, again, that's what I was solving for. My y was 10 and my x was 3. So my point of intersection is 3 and 10. So, it's a good question. How did I know to multiply by 3 and 4? I could actually multiply by other numbers. If you're unsure, you can always multiply the one equation by the variable of the coefficient of the variable that's opposite of it. So, in the first equation, I'm trying to get rid of my x. So in order to do that, the other x in the equation has 4 in it. I can just know to multiply by that coefficient, the opposite variable's coefficient. Same as the other one. I decided to multiply by 3, this equation. So take the coefficient of the other variable to multiply it into the equation. It will always work to get you the same coefficient. Then from there you have to decide whether you want to add or subtract though. So your homework, page 40, 1, 3, 9, and 12. Don't forget your homework from 1.3, which you're supposed to have done in class.